So, hello everyone, and I'm Yixi Chen. Today I'll be talking about how to build your own 5G network. So, because the PDF I submit is without the animation, so I will use the laser to try to point out what I'm trying to say. And then because the time is really limited, so I will skip several slides. Like if you have questions, you can just ask it at a Q&A session first. So I'm Yixi Chen. I'm from Taiwan, and I was studying my master's degree in Beijing. And now I was working as a research assistant in University of Singapore and on 5G networks. I also participate in different open source communities in Singapore, Hong Kong, and Taiwan. Yeah. So today I will be talking about several topics and what's covering and what is not covered in this presentation. And before we go to that, we have to clarify that the following opinions are solely based on my own experience and has nothing to do with the US from yeah. So first, I'll be talking about the fundamental of the 5G network, how it was built, and how it should work as a fundamental, essential knowledge for anyone at least to know. And second is the modularized solution. The modularized solution is how the 5G network open interface break the previous monolith design into modularized container, modularized design. And finally, I will briefly talk about the performance of such open interface 5G network. And so it was more about engineering, how to do it, how to make it work. So what I will not cover is how to make it a product. So the current reliability of such project is still a misery. Still, you cannot rely it to provide a reliable service. So I will not cover it to how to make it more reliable, how to make it a product. And second, making a 5G network requires to apply for regulatory compliance, which means that you have to ask the government about how the spectrum you are using. So also, this kind of issue is very different from places to places. So I will not cover this part also. So we have go over the table of contents that shows the basic of how your user equipment connects to the network. So this is the very brief diagram of how the phone connects to the network. So first, the user equipment. In the previous state, the user equipment is just the terms defined in the spec. Just like it represents your phone, the 5G modem, everything that can send or receive 5G signal at the edge is called user equipment. And there's another useful term or very common term you need to memorize is the GNOB. The GNOB is just a base station. It is a base station for 5G. There are different names for 4G and previous network, but for 5G, the name for the base station is called GNOB. So in the previous case, the user equipment, like in 4G and in the early 5G, this 5G network is put into a big black box. So your user equipment just connects to a big black box, which is provided by the provider, the device provider like Cisco. They provide you with a very vendor lock-in solution, and your user equipment connects to that device, and the device will do everything for you, and everything is done. So the telco modern days doesn't want that because they want open interface. They want to configure stuff by themselves. So instead, the whole structure breaks into different parts. So first, the user equipment connects to the local base station. The base station is responsible for the signal processing, everything, modulation, scheduling, very base, lower end, layer 1 packet processing. And then such signal packet is then forwarded to the core. The core, on the other hand, requires more about the policy, like the SIM card variation, like the billing policy, how do you charge the client. This is all done on the core. The core is more about management control. And finally, the packet is then forwarded to the IP network. So what is the 5G base station? What does it do? I will briefly go through it. It basically have to do it's just like the antenna stuff you will see on the roadside. it have to do with the radio demodulation, how to do with the signal transmission, and it also have to manage the spectrum usage, because spectrum is a very pricey resource. It is very limited in every country. So you have to efficiently manage the spectrum from different user equipment, the UE. And then, so one way to do is the UDD-DVD. This is a detailed configuration. You can just ignore for now. How to efficiently spread the resource. So this is just how to do it. And the last one is the mobility. The mobility is especially a term for how the UE, your phone connects to different base stations to try to make sure your signal remains stable across different when you are moving. Just like how what the GNOB should do. So in order to break the GNOB into different units, there are 3 different logical units. So first, the signal comes from ocean. The signal comes from the UE. The UE, first, the UE, the RU, the radio unit capture the wireless signal from the UE. So the RU have to do all the signal processing, just like previously discussed. And then the processed signal then forwards the packet to the DU. The DU is a distributed unit, which is responsible for the scheduling, resource management, anything. The DU. The DU finally forwards the packets to a CU. The CU is for the higher end control, but still relatively lower plan. It's like layer 1, layer 2 control. So the CU lastly forwards the packet to the core network. So the core network is just a bunch of network functions in a container, runs on a single switch, on single server. Yeah, mostly run on a single server. You can scale it, but yeah. And then the 5G core is responsible like the SIM card variation, the authentication, authorization, or the session management to improve the quality of service, the QoS, or the network slicing. The network slicing is a new idea in 5G network. It tries to split a single physical network into different virtual network for different needs. Like you can do a very low latency virtual network and stuff like that. This all stuff is done within the 5G core. And this is the structure of how it will split the packet from the GNOB, the base station is first. It branches into one. The control signal goes to this path, is responsible for the mobility and the network repository functionality in different containers for different functionalities. And these are all within the control plane. And this one is for the data plane. So this is basic view of how it works. So for data path is just like the message on your phone. Maybe you just send a message on WhatsApp, try to message someone. This is called data path. What is the packet will go through? The packet will first send from your user equipment, and then was captured by the RU, and RU later do the modulation, demodulation, and then send back to the DU. And DU do the scheduling and send to the CU. The CU then forward the packet to the core, and the core, the packet will through the UPF, this function, and to the IP network. And then for data signal, the control signal is like you have to verify your SIM card. You have to how to control the building, like you calculate the bandwidth the users have already used. So the data path, how the direction, how it works is more complicated. So we are not going to discuss here. But it's how it will look like when you are using the open interface 5G network. So what are available solutions to build your own available 5G network? There are one solution we are using is called OAI interface, and I provide the link in the lower left section. So maybe if the slide will provide it, you can just refer to the link below. So it provides with different kind of settings that you can, that for UE, GNOB, core, they have different settings. Like for UE, your user equipment, you can be either stimulation by software, or you can use your own phone, use your own cell phone. And for 5G GNOB, it also provided with 2 solutions. You can use either software solution or use your own hardware. And then, but final one, the core. The core can just be the software. The core is just done by a bunch of containers running maybe a server or just a server running on servers. So this is OAI, these OAI tools, and I have to say that OAI has very rich documentation, but it is not maintained by ours. We are just using it to do development. So there are another solution called SRS RAN, but this one also supports building your own 5G network. These are the two top-tier open source 5G solutions. And this solution provides, it can support more UEs, open source UE. But we choose the previous one simply because it can work. So as a brief, you can do just entirely on software. You can, for instance, this is a minimum deployment. And I just don't mention everything about how to exactly do it because everything is very well declared in the documentation. In the reference, they are well documented, and there were scripts that can help you turn out every container with a Docker Compose. So everything was very. If you want to go for a software solution, everything was very smooth and easy. So what can you? So I will not be mentioning it. If you want to do more detail, you can just see the documents. So it can support like a very minimum deployment. You build your own core network and use your host to connect to the core network to test if it works. Or you can build a whole 5G network, including your UE, your phones, your GNOP, the base station, the core network, all on containers, everything on containers. So everything was stimulated. So this is, if you want to do a software approach, you can do it. Like within 5 minutes. It's very easy. But what can you get from such topology? You can get the packet trace, you can know how it works, how the 5G network works. But if you still want to connect your phone to this 5G network, then that will begin the real part of challenge, how to make your phone accessible for the 5G network. So there are several things you have to do before connecting your phone or anything physical hardware to the 5G network, OAI 5G network. And then for now, first part we talk about the UE. The UE, you have two choices. The cell phone, everybody has a cell phone, and the 5G models, which is used specifically for the 5G signal transmitting and receiving. So for the first one, the cell phone, it is a very tricky part. Can you use a cell phone to connect it to it? Yes. But how to do it? That is a very tricky part. So the cell phone comes with a very high performance compared to the 5G models, but it is very hard to make it work. I will talk about why this is hard for it to work, but briefly, the cell phone comes with a very wild ecosystem. Everything was very huge, massive. It is hard to configure it on each phone. So we are now successfully use the OnePlus 8 Pro and the Google Pixel, and we will have to try the Xiaomi phone. But anyway, it's very hard to make your cell phone connect to it. And the 5G modems is on the other hand, it is very easy relatively easy to connect, but with I don't know why, but it has a lower performance, and we are using this to And then in order to have your cell phone available for your 5G network, you also have to buy an open source SIM card. The open source SIM card is available across the network, and we are buying it from the open source project. And then it's necessary because you have to register the SIM card within the network, so you have to read and write the SIM card. So this is two requirements. And so we move on to GNOB, the base station. So the base station you will expect is the huge one with the multiple antenna. It's very, very, very expensive. Many people are not going to buy it. So there are other choice called another open source radio unit available on the market, such as the USRPB 210 But there are still other ones, maybe from Bellatel. There are still others available, but way more expensive than this one. This one is, so far we find the cheapest one, available. And then it also is pricey in a way, and you have to configure it, make it work. We are plug it into the server we are using. And this frequency band setting what we were talking about, I will ignore it for now. If you want to use the default frequency, it will be fine. You don't have to worry about the frequency tuning. But if you want to set your own frequency, then you will have to go through every details in the 5G network. But yeah. So and the next thing you have to do if you want to go for a customized 5G network is the signal isolation. So if you doesn't get the permits to run your 5G spectrum, you have to keep all the signal within the same environment, in the closed environment, or you could be sued or be fined. So we are currently using a tent, a Faraday cage tent, but you can still use a cage, something like that, to keep every signal, 5G signal, within this cage. So every experiment has been done within the cage before you apply for real document for operation. So what is our testbed for now? Our testbed is first the UE. The UE, the user equipment, could be phones. The phone could be the OnePlus 8 Pro, the Xiaomi, the Google Pixel. And another choice is the 5G modem. 5G modem we are currently connected to the server, and this is just a USB connection. And these two are connecting to the RU. RU is a real hardware called USB 210. They are connected through wireless signal and transmit the packet, transmit signal to RU. And RU and the DU and CU are the units on the GNOB. And it was based on two different servers, and these two are containers, and this is a physical hardware. And then after the GNOB, the 5G core are just a server, and with a bunch of containers runs upon it. And then finally, after the core, it was connected to the public network. So this is our test bed. It looks like this one. Yeah. So we discover some interesting behavior with such network, like we discover some attributes. For instance, it takes more time to send uplink than downlink. The uplink is from the UE, and the UE from the user equipment from your phone to the public network, and the downlink is opposite direction from the public network to the UE. So the possible reason is due to the settings, but we'll go there. I don't have enough time, so I will just ignore it. The possible reason. The reason can be how to set the TDD's configuration, but it's a bit lengthy, so yeah, skip for now. And we also discovered that the physical processing on the RU plus DU takes almost like 90% of the time, the whole processing time, which means that the RU is very important for the overall round trip time. So we are currently buying a new RU with like triple the price, trying to make sure that it is not a bottleneck. And the next one is the CU. The CU has a really long tail processing time. The real long tail processing time will lead to a poor quality of service, which means that several customers, like 1% of customers will experience a very extreme high of latency. In this case, 800 times of latency. So it is kind of like weird behavior, and we suspect it to be a like software implementation error or something like that. So for experience, what you should like, this is how we, with a painful learning experience we got from building our 5G network. But first, the phone. Okay, the phone is most people interested, but how can you get the phone works? From our experience, you have to get the root access to the phone first. After you get the root access phone, you can configure the frequency band you are using. But most phones have dedicated frequency band locked in on their phone, maybe because they are selling on a specific region. So you have to manually revert the settings and try to using the root access to reconfigure the available band acceptable on the UE. So first, you will need a root access for the phone, for this phone. And then it could also be the firmware update. The firmware updates is something might also mess up with your connection. So maybe during your sleep, the firmware just updates. So the firmware update, so your previous setting no longer works. So it cannot connect to network anymore. So this is what happened in our settings previously. These are just two examples. There are way more. But like for a phone to connect to network, it's very unstable and very suspect, make your life very hard as a developer. But as a 5G model is more easily it's used for development. So you will have a richer document on how to debug. So it was easier for you to as a developer, but as a user you might still want to go for a phone, but it is very painful to develop based on the phone. So these are just trade-offs. If you want to go for high performance, you just go for the phone. But if you want a happy developer debug life, you maybe go for the 5G models. And for the RU, the radio unit, the radio unit is also very important for the signal processing. And signal processing is like, it requires a very high level of learning, deep learning of how the frequency works in order to apply your own custom 5G signals. And this is a very, very steep learning cost, very steep. So you have to notice that the signal, the frequency you are using could be not that friendly. And the last one is we are using this one, and this one is very cheap. It's relatively cheap, but it has very limited throughput, like uplink around like 4 Mbps and downlink with 30 Mbps. So the throughput is very, like not that high, so it's also a bottleneck for the whole network. And then the core network surprisingly works fine. We can even watch a 4K video on the OnePlus 8 Pro with this core network. So the whole ecosystem works, but the core network sometimes fails, but it fails not that frequent. Just like the RU and this one fails very easily. But the core fails not that frequently. So let's go up with my presentation. I will very thankful to my colleague, and thank you all for listening. Any question?
Many thanks for your presentation. I just have two questions. First one, I would like to ask, can you go back to the last previous slide? Okay, this one is okay. For this one, I would like to ask two questions. One is, can you make the test for the UE handover?
What? You mean the UE handover?
Yes, UE handover in this testing scenario.
You can, in the default, you mean UE handover, you mean what kind of handover? You mean the migration, or what kind of handover?
For example, on the handover between when you make a move, I mean,
move from
one RU to another
GNOB.
Yes.
Yes, this is also another, like we try to evaluate in our next step. But this is a tricky part that we still not sure if this framework or this project, because the project is updated on a weekly basis, and we are not sure, and we are more likely not covered yet the migration part. It already done several parts of network slides trying to migrate, but the overall structure is not finished yet, so we are not sure if it works or not. It's more about the project is not covered this part yet.
Yeah.
So
yes.
yeah, so yeah, we maybe cannot support the migration for now. For what I know, yeah, maybe not. Yeah.
Yeah, and the second one is, I mean, a small question. It looks like your cache is quite big one because you put DU, CU, and core in the.
Actually, we are using wait. We are using the tent. This is actually a tent. We are not using the cage because the cage is too small, and we want to put over a server within the storage cage. So we buy a tent, and the tent is very expensive. And my colleague says we maybe don't want to expose the price. So it is we are not buying the cage. We are not buying this cage. We are buying a tent. This tent, a tent. We are buying a tent instead of cage. And so yeah, we are not using the cage because the cage is too small. Yeah.
Okay, thank you. It's clear.
Yeah.
Dạ, anh chị có câu hỏi nào nữa không ạ? Dạ, ok.
Hello. I would like to ask if I want to connect to a public network, that I need a document from the operator, or
no. If you want to connect, what do you mean by public network? The IP network.
Can you show the later slide? The next to last, I think.
Okay. Yeah, this one. Okay, this one. Okay.
The public network is
just an outer network that the network connect to this one. It can you can reach the if this network is connected to the outer network, it can already you can reach the outer network. If this server is connected to the outer network, yeah. Any question? Okay. So basically, the whole if you look through the documents of OAI, you can get a really smooth of migrating from a pure software solution to hybrid solution. But like you still have detailed implement. They are not very reliable on the hardware because the hardware iterates very fast. So you are very likely to have troubles when you migrate from pure software to try to bring your phone in. That is the high challenge, but this is motivation. Why do you want to build your own 5G network? So yeah, this is the kind of like conflicting issues. Yeah. And also a point worth mentioning that I just mentioned that these parts are all virtualized, but actually the RU recently, within the 1 or 2 years, there are research in Microsoft. They already applied for patents to try to virtualize the RU. So they call I forget. They try to virtualize everything. The RU is virtualized within the data center, and this is already virtualized already virtualized. So you can expect that the next generation, maybe 6G or maybe at least next 6G, every network processing will be done on the cloud. This is the big picture of what the big company are trying to do. They try to virtualize every 5G component